Alright, the next property of a wave we're going to learn is called the wavelength. So the wavelength, because it is a length, can only be obtained from a displacement distance graph. Alright, so what is a wavelength? The wavelength of a wave is the shortest distance between any 2 points in phase. Alright, so now that you know what 2 points in phase means, this is relatively easy to understand. Alright, so can you try identifying a wavelength? Right, so P and S are in phase. So the shortest distance between these 2 points, which is this line here, is called a wavelength. Right? Of course, P and V are also in phase, but the distance between P and S is shorter than the distance between P and V. So this is the shortest distance, so it is a wavelength. Alright? Can you identify other places that show the wavelength? Pretty straightforward, right? So Q and T is also a wavelength. The distance between Q and T is also a wavelength, and the distance between R and U is also a wavelength. Alright, so the wavelength is, put simply, the length of one complete oscillation. Okay, so wavelength means length of a wave. Length of a wave is length of one complete oscillation, so that is the wavelength. Alright, so in case you're wondering, this sign here is the symbol for wavelength. The symbol for wavelength is this, so let me write this here. So the symbol for wavelength is lambda. Alright, it's written like this. It's called a lambda. It is a Greek alphabet. Alright, so L. Okay, you don't need to know how to spell it, So lambda. The Greek alphabet is lambda, and the units. So the SI unit, it's a length. So what do you think the SI unit is? That's right, it's meters. And of course, the units could be given to you in other units in the question. Could be centimeters, so on and so forth. But the SI unit is meters, so be mindful of the units. Alright. So does the wavelength has to be from the crest or from the equilibrium position or the trough? No, right? So any 2 points in phase, right? So a point here and a point here in phase. This distance is also a wavelength. This distance is also one complete oscillation, right? But of course, it is most straightforward, easiest to see from the crest, the troughs, or the equilibrium position. All right. One good and clear way to always identify is, of course, the length of successive crest to crest or trough to trough. Okay, so what does successive mean? Successive means the next immediate one, right? So the next immediate. So either the next immediate crest or the next immediate trough. So this is a crest, the next immediate crest is here. So this distance is one wavelength. Alright, similarly, the successive trough. Yep, so this is a good way to identify a wavelength. Alright, let's see if you've caught that. What is the wavelength of this wave? Right, so of course you could go crest to crest if you had those values, and actually you can get those values, or you could go this point here to this point here. So if you said 40, you'll be correct, but only half correct because you still need to include the units. So the wavelength is 40 cm. Okay, so this is 10, this is 50, it's still 40 lah. The wavelength of a wave is always the same. Okay, just to be clear, the wavelength of a wave is the same no matter where you measure from. It will all still be the same. So this will be 40, this will be 40. From here to here will also be 40. Okay. Sorry, I'm not drawing very well. Alright, so yeah, that's the wavelength.